Ever considered the profound impact of statistical analysis in Python? It goes beyond just being a powerful tool. It is a vital framework that aids in unraveling the intricacies of data, making informed decisions, and predicting future trends. The magic of statistical analysis in Python extends to a multitude of fields, including data science, machine learning, and artificial intelligence. In data science, it forms the backbone for dissecting large data sets, revealing patterns, and providing valuable insights. In the realms of machine learning and artificial intelligence, it lays the groundwork for algorithms to learn and adapt, helping machines evolve and become more efficient. Today, we delve deeper into the world of Python, unlocking its potential, and explore how to perform basic statistical analysis. Its importance cannot be overstated as it continues to revolutionize data comprehension across sectors. Begin by incorporating the required libraries. Python offers numerous libraries, but this tutorial will primarily utilize Pandas, NumPy, and SciPy. Pandas, a software library, enables data manipulation and analysis, providing data structures that make working with structured data fast, easy, and expressive. It is built on top of two core Python libraries, Matplotlib for data visualization and NumPy for mathematical operations. With Pandas, you can clean, filter, and statistically analyze data. NumPy is a Python-specific library that amplifies support for large multidimensional arrays and matrices. It includes a wide assortment of high-level mathematical functions that operate on these arrays. NumPy is crucial for statistical as it provides fast numerical operations via its high-level mathematical functions and multi-dimensional arrays. This efficiency is pivotal when dealing with large data sets in statistical analysis. SciPy, another Python library, is utilized for scientific and technical computing. It builds on NumPy, allowing manipulation and visualization of data with a wide range of high-level commands. SciPy is designed to work with NumPy arrays and provides many user-friendly and efficient routines for scientific calculations. Python also offers other libraries for statistical analysis. Matplotlib, for example, is a plotting library that works with Pandas and NumPy for data visualization. Seaborn, built on top of Matplotlib, provides a high-level interface for drawing attractive statistical graphics. StatsModels is another library which allows users to explore data, estimate statistical models, and perform statistical tests. All these libraries work together to serve different purposes in the realm of statistical data analysis in Python. Before we begin, it's crucial to ensure that the required libraries are already installed in your Python environment. Here's how you can check. First, open up your Python environment, type import library name, and hit enter. If the library is installed, there won't be any errors. If it isn't, Python will throw a module not found error. If a library isn't installed, don't worry. It's easy to install it using the pip install command. Just type pip install library name in the Python environment and hit enter. Your system will automatically download and install the library for you. But remember, merely installing libraries isn't enough. It's equally essential to keep them updated. Outdated libraries might have bugs or lack the new features of the updated library, which might hinder your Python experience. To update your libraries, use the command pip install upgrade library name. It ensures that you have the latest version, providing you a smooth coding experience. The next phase involves bringing in these libraries into the Python environment. This is done using the import command, which is followed by the library name. Essentially, the import command in Python is used to include external libraries, modules, or functions into your script so they can be used therein. For example, to incorporate the Pandas library, you would use the import pandas as PD. Likewise, import NumPy with NP and SciPy with from SciPy import stats. The PD and NP are aliases for the Pandas and NumPy libraries respectively. These aliases are utilized primarily for two reasons. First, it makes the code more concise and easier to type, reducing the chances of errors. Second, these aliases have become a standard convention in the Python community, making the code universally understandable. Understanding the significance of basic statistics such as mean, median, mode, and standard deviation is crucial when analyzing a dataset. These statistical calculations help to summarize and give a comprehensive snapshot of data distribution and its central tendency. Now, let's delve into what each of these represents. The mean, often referred to as the average, gives us a central point of the data. Median, on the other hand, is the middle value in a dataset when arranged in ascending or descending order, effectively splitting the data into two halves. The mode represents the value that occurs most frequently in the data. Lastly, the standard deviation is a measure of how dispersed or spread out the data values are around the mean. In conclusion, these basic statistical operations provide key information about the dataset, helping analysts make informed decisions. Python, being a handy tool for data analysis, offers straightforward functions to calculate these statistics. The mean, often referred to as the average, is a statistical concept that represents the central or typical value in a set of data. It is calculated by summing all the numbers in the dataset and then dividing that sum by the number of data points. For instance, if you have a dataset consisting of the numbers 1, 2, and 3, the mean would be 1 plus 2 plus 3 / 3 equals 2. To help compute the mean of a given dataset, we can utilize the mean function from the NumPy library. As an example, invoking np.mean dataset will return the mean of the mentioned dataset. The calculation of the mean is particularly useful in a variety of situations. For instance, it can help in assessing the performance of students based on their scores, in understanding the average temperature or rainfall in a particular region, or even in financial contexts, for calculating average income, stock prices, etc. It offers a quick snapshot of the dataset, providing a single value that attempts to describe a set of data by identifying the central position within that set. In the next step, we tackle the task of calculating the median. But what is the median exactly? Well, it is the middle value in a set of values. It's calculated by arranging the values in ascending or descending order and then identifying the value that falls exactly in the middle. If the number of values is even, the median is the average of the two middle numbers. We achieve this using the median function. The command in our case is npmedian dataset. Now you might wonder why one should calculate the median. The median is incredibly valuable in situations where you need to determine the central tendency of a dataset, especially in the presence of outliers. These outliers can dramatically skew the mean, while the median remains relatively unaffected. Therefore, the median provides a more accurate representation of the central tendency in such cases. The mode in statistics represents the most frequently occurring value in a dataset. Unlike mean and median, calculating the mode involves identifying that repeated value which appears most often. To find the mode, we use the SciPy library's mode function, available in the stats module. The command for this would be stats.mode dataset. Mode calculation is particularly useful in situations where you need to identify the most common item in a dataset. For instance, if you have a list of the most popular movies watched, finding the mode would give you the movie that viewers watched the most. Thus, understanding the concept of mode and its computation is vital for data analysis and interpretation. The standard deviation is a measure that quantifies the amount of variation or dispersion of a set of values. It represents how spread out the numbers are from the mean value. The standard deviation is calculated using the std function from the NumPy library in Python. For instance, by writing np_std dataset in your script, the program will return the standard deviation of your dataset. Calculating standard deviation can be useful in many situations, especially in statistics and data analysis. For instance, in finance, it can be used to quantify the volatility of stock prices. In scientific research, It allows researchers to determine if the differences in their results are significant or merely due to chance. In these and many other fields, the standard deviation plays a crucial role in understanding and interpreting data. Let's delve deeper into the concept of hypothesis testing. It's a powerful statistical tool that aids in making informed decisions based on experimental data. But what exactly is hypothesis testing? It's a method used in statistics that allows us to test an assumption regarding a population parameter. The methodology deployed involves 4 steps: formulating the null hypothesis, choosing the significance level, computing the test statistic, and making the decision. The reason behind its usage primarily lies in its ability to test the viability of a claim or idea in a systematic and scientifically sound manner. Hypothesis testing enables data-driven decisions, reducing the chances of making erroneous judgments. It also helps in debunking false claims based on data analysis. Python, a popular programming language, offers various ways to conduct hypothesis testing, enhancing its accessibility for data enthusiasts and experts alike. A t-test is a statistical hypothesis test, widely recognized as one of the most prevalent methods in data analysis. Under the null hypothesis, which is a general statement or default position that there is no relationship between two measured phenomena, the test statistic of a t-test follows a student's t-distribution. When it comes to executing a t-test, the function called t-test_in from the SciPy library is typically employed. This function takes 2 data samples and returns the calculated t-statistic and p-value, providing the results of the t-test. Now, you might be wondering when to use a t-test. Well, it is primarily utilized when you want to compare the means of 2 groups and see if they are different from each other. It can be incredibly useful in situations where you have a limited sample size. The results of a t-test are equally important. The t-value that the test generates tells you how much the groups differ, while the p-value informs you about the probability that the results could occur by chance. Hence, if the p-value is less than the decided significance level, we reject the null hypothesis and conclude that there is a significant difference between the 2 groups. To succinctly summarize, this tutorial delved into how Python is a robust platform for conducting elementary statistical analysis, highlighting the utilization of key libraries like pandas and SciPy. We explored fundamental concepts such as mean, median, mode, standard deviation, and even dove into hypothesis testing with the t-test using SciPy. The power and significance of statistical analysis in Python cannot be overstated. It's an instrument for comprehending and interpreting data. However, the journey doesn't stop here. I encourage you all to deepen your understanding and venture into more advanced statistical techniques, as it will further strengthen your data analysis skills. Remember, the world of Python statistics is vast and ever evolving, so carry on exploring, keep broadening your knowledge. Happy coding!